All right, here we go. So now we're going to talk about evaluating geometric series, infinite geometric series. So let's start with what a finite series is. So for a positive integer, again, for a positive integer n, the series denoted the summation from I equals 1 to n of a sub I, which equals this sum, is called a finite series because obviously there is a finite number of terms. That's it. Okay? The series where I goes from 1 to infinity of a sub I is called an infinite series because there is an infinite number of terms. It's that simple. Okay? Now, when we look at the nth partial term, like for a finite series, so we're looking at the nth partial term, or nth partial series. Or the nth partial sum. Okay, here we go. It says oops. Okay, so now if the nth partial sum of an infinite series, so we're talking about an infinite series, right? Because we want to know, hey, if it's an infinite series, is it possible to find where this sum is going, right? Because if it's infinite number of terms, we want to know, hey, is it approaching something? So that's one of the questions that comes up in infinite series. So if the nth partial sum of an infinite series approaches a number L as n goes to infinity, then we say that the series converges. And we call L the sum of the series. Now, Now, if the series does, or the partial sum rather, if the partial sum does not converge, right, then what we say is that the series diverges and the sum does not exist, right? So either a series is going to end up converging, right, the partial sum, right? So the partial sum will either converge and seem to go towards a particular number as n goes to infinity. And in that case, we say, hey, this series converges. And the number that it converges to, L, is called the sum of the series. Otherwise, if that's not the case, then we would say that the series diverges and the sum does not exist. So for example, what would be a divergent series? A divergent series would be one that the sum, the partial sum, seems to be going off to either positive or negative infinity, right? If that's the case, if the sum just keeps getting bigger and bigger and bigger, the partial sum keeps getting bigger and bigger and bigger, then, and it doesn't seem like it's going towards any value, then we would say the sum does not exist, and the series is divergent, okay?